Hello guys, welcome back. In this video, we'll be discussing how to find number of digits of a number. Let's try to understand the inputs as well as outputs. So 1, 2, 3, 4, 5, there are 5 digits. Output is 5. Similarly, 1, 2, 3, 4 to 4, 8, 92 to 3. Before moving on to further discussion of this logic, so I suggest you to go through bitwise operators part 2. So where I have detailedly explained about right shift over there. So now let's try to understand the given number 1, 2, 3, 4, 5. So in order to find number of digits of a number, so what we are supposed to do? So the logic over here is, so each and every time when we are able to remove each and every digit from that. So let's say the first time I've removed the value 5. So next time I'm removing the value 4. Next time I'm removing the value 3. Next time I'm removing the value 2. Next I'm trying to remove the value 1. So like 5 times I was successfully able to remove the values. So meaning there are 5 digits. So until we were able to remove the digits from that given number, so we can simply assume that so that number of digits are present in that respective number. So in order to remove the last digit, what we are supposed to do? So basically right shift means so dividing with the base. So normally right shift works on binary base, basically base 2. But in order to remove something on the decimal base, I want to remove the last digit 5. So I'm supposed to divide with the value by 10. So if I take the value 1, 2, 3, 4, 5, so divide by 10, so we get the value to 1, 2, 3, 4. Similarly, 1, 2, 3, 4, you divide by 10, the output would be 1, 2, 3. So 1, 2, 3 divided by 10, you get it to 1, 2. 1, 2 by 10, you get the value to 1. Similarly, 1 by 10, you get the value to 0. So even if you try to divide it further, there are no more digits to divide. So meaning here is you start from the value 1, 2, 3, 4, 5. So until 0, you keep on dividing the value by base 10. So at each and every time, like what if you increment the count by 1? So initially assuming the count to be 0, now count to 1. Similarly, count to 2. So count to 3 over here. Similarly, count to 4 as well as count to 5. So initially we just take our number to 1, 2, 3, 4, 5 as well as we take our count to 0. So at each and every step, simply divide by 10, increment your count. So once the number is reaching 0, we need to stop. So if you observe carefully over here, we are checking the condition until our number is reaching 0. So meaning, so until our number is 0, we are supposed to divide by 10. So here comes a picture of the loop called while. So as we discussed, while loop stops when the condition is failed. So here we can write the condition saying while our number is greater than 0. So while our number is greater than 0, you keep on dividing, you keep on incrementing your count. So let's try to write this code in our Visual Studio Code. I have created a file called number of digits with the extension .py. So let's take the input from the user, number to int of input. So right, so we need our count value starting from 0. So until our number is greater than 0, we are supposed to keep on dividing the number by 10. So divide the number by 10, right? So increment your count value by 1. Doesn't matter if you change the order of these two lines. So either you can increment the count first as well as then you can divide the number by 10. But even this also works. So let's try to print the count. So let's try to run this code. All right. So giving the value 1, 2, 3, 4, 5. So output is 5. Similarly, let's try to give 1, 2, 3, 4. Output is 4. Now let's try to give 1, 2, 3. Output is 3. So like based on the number of digits what you're trying to give, so we are able to successfully see it. So what is the time complexity of this program? So in order to say what is the time complexity, so let's say, so normally we usually think time complexity to be order of n, but it's not order of n. So when you say order of n, when this loop runs for 12,345 times, so then we say it to be order of n. But the time complexity of this program would be order of log n. So while log comes into picture, so you can simply remember this point at this moment. So whenever division or multiplication comes into picture, so log will be automatically coming into picture of the time complexity. So as you are dividing by 10, so we can strictly say log 10 of the given number is the time complexity. So that's all for this video, guys. Thanks for watching. See you guys in the next one.